So I've just explained the dipole and the quadrupole, and they work for a perfect system where you have a beam going around in a circle, and we know all the properties of the beams very precisely, and everything looks fine. Unfortunately, that's not always the case. You get small beam aberrations because you get a slightly different magnetic field to what you expect, and that can change the shape of the beam. So to correct for this, we have the sextupole and the decapole, and these allow us to fine-tune the bits of the beams which are looking the wrong shape. And we need constant vigilance to make sure that these kinds of instabilities don't lead to beam loss. So what happens when we have beam loss is we have what's called a beam dump. The LHC team realised that the beam is not recoverable and that these errors are too large. They start a sequence, and then the beam actually gets dumped into a special structure of concrete. Now, when this happens, it has the kinetic energy of a freight train going at 60 miles an hour. So this means that there's a lot of energy to dump, and they have special cooling systems for this concrete. And you can actually see cooling towers around CERN, where the beam hits the concrete, it gets cooled down, and it gets released to steam. And so this is the way they actually deal with the loss of beams. And they try to minimise the loss of beams by using these decapoles and sextupoles to correct for the small aberrations they see.